Hello guys. Today's topic is KFold cross validation. So in this video, what we are going to see is what KFold cross validation is, and why it is used, and why we should use. So basically, K4 cross validation is used in a case where we have very less data set, and you want to see how it performs on unseen data. So actually, if you have a data set with very small size, so you cannot split the data set into train and test, because it will actually reduce the size of training data. And also you cannot use the same training data to test your model, because it will be like training the model on the same data and testing it on the uh, same data. So this will create a problem of overfitting, because it is not tested on unseen data. So for these cases we use cross validation technique. So we will use a live we will see this using a hands-on demo, like how K4 cross validation works. So I'm going to use Jupyter Notebook for this. So if you don't have Jupyter Notebook, or you don't know how to use Jupyter Notebook, so the first thing you need to do is install Jupyter Notebook. And you can Google it how to install Jupyter Notebook. And once you have installed that, the command that is used to run a Jupyter Notebook is Jupyter-notebook. So this will launch Jupyter Notebook in your Chrome, or whatever default browser you have set. So it will look something like this. So after that, what we will do is we will create a new Python. I'm going to use Python 3 for this tutorial. So I'm going to click on new, and then notebook I'm going to select is Python 3. So here we have one notebook. So we will name this as KFold cross validation. So we have our Jupyter Notebook ready. So what we are going to do is we are going to create an array, and I'm going to show you how you can split that array into a train and test dataset. So the packages that we will use for this module is NumPy and uh, KFold from sklearn. So yeah, let's get started. So the first thing that we need to do is NumPy import NumPy from Im- oh sorry from from numpy import array. Okay. And the second thing that we will need is from sklearn. Okay, we will import this as we need. So the first thing that we need to do is we can create an array. We can create an array is equals to array of size. We will create 12 digits. So one two. So this will be your you can consider this as a training data. So this is just an example to show you how we can use, and later on we will use this with a IRSS dataset to actually see how KFold performs on that dataset. 9, 10, 11, 12. Okay, so let's check the length of the array. So the length of the array is 12. Okay, fine. So we are good to go. So the next thing that we need to import is sklearn. Sorry, the next thing that we need to do is we need to import KFold. So from sklearn dot model selection. Sorry, sklearn dot model selection import KFold. So if you want to see the suggestion in Jupyter Notebook, you can press the tab as we type. So KFold. Okay, so we have imported the KFold. So we are going to now use this. So KFold, sorry, KFold equals KFold of, and suppose you want to see what parameters are going to be used in this function. So what we need to do is we need to press shift and tab. And if you want to change the shortcut, you can go in here, and there is one option to change the shortcut. So you can change that. So for me, or for by default, the shortcut given to see the parameters in Jupyter Notebook is shift plus tab. So you can see we have split we have this option split, shuffle, and random state. So split, what it does is it creates an array of test and train and test splits. So suppose we give split has three, so it will create three pairs of train and test dataset for us. So I will use four for this, and I will use the second option was shuffle. So what shuffle is, shuffles the training before splitting the data. It shuffles the data for us. So we will use shuffle is equals to true, and random state is one. So our KFold has been defined, and now what we are going to see is we are going to see how KFold separates the test and train data spread for us. So let's check this for train comma test, test in KFold. So before this, let's see what is KFold.split. KFold.split KFold.split data array. Split array. Let's check what is this KFold. Okay, this is KFold, not KFold. Okay, so it gets a generator object for us. So it is not an array. It is not an array. It is generator object. So let's print this out. For train comma test in KFold dot array split array print data of array of train comma array of test. So let's make this look better. Test. So let's make this better. So test colon this test data set, and we are going to write for test data set as well. So test colon this. So now we can see that we have defined our splits as four. So it is basically created four splits for us. So as we can see, it has created three for test dataset, and the remaining nine for test dataset. And we can see the inputs are not same, and it is shuffled. So 1 2 6 7 8 9 10 11 12. Then we can see 1 3 4 5 6 8 9 10 12. So this dataset has been shuffled. It is not the same dataset that it is giving us. So now, as we have seen, this are four combination of test and train data spread. So basically what we do is we use four combination of model for this test and train data set. So this is test and this is train. So what happens is, let's consider this as test one. Let's consider this as train one, this as train two, train three, train four. So what we finally we will have is we will have a combination of like model one, which will be trained on train one plus test one, and it will be tested on uh, test one. Similarly, we will have combination of model two that will be trained on train two data, and it will be test on test two data. Similarly, we will have model three that will be trained on train data three, and it will be tested on test data three. Similarly, we will have fourth one that will be tested on four, trained on four, and we will give it a name as four. So basically, we have four data models for this. So let's suppose we get an accuracy of 89% for this, and we get an accuracy of, for the second we get an accuracy of 89.5544, and for third we get an accuracy of 90, and for fourth one we get an accuracy of 95. So basically what we have is we have a combination of a model. So we can see that it performs really well on all the four data sets. So this is how it works in model selection. This is how it helps us in model selection. So now what we are going to see, what we are going to do is we are going to use the IRSS dataset to actually see how it helps. How it So now what we are going to do is we are going to actually use the IRSS dataset to classify the IRSS into different classes using a support vector machine, and we are going to see how KFold cross validation actually increases the accuracy of that. So let's import dataset and SVM for this using sklearn. So form sklearn import datasets and form sklearn import svm support vector machine. So we have this, and we will first use train test split to actually split the data set into train and test, and after that we will use k4 cross validation to test how it actually improves the accuracy of this dataset. So this dataset is really small, like it has 150 uh, it has 150 rows and 150 rows and 4 columns. So let's see this using this. Okay. So now we have imported all the required packages for us. So let's see how the IRSS dataset looks. IRSS is equals to IRS dataset dot load underscore IRSS, that load underscore IRSS, and let's check its shape. How does it look? Data dot shape. So it has 150 rows and 4 columns, and let's see what is the shape of target that we have. Dot target dot shape. So target will be basically a number, and it has 150 comma nothing is there, that means 150 comma 1 we have. So we have this number 0 1 and 2. So basically these are three categories in which we need to classify this data set. So we will use SVM model for this. So the first thing we need to do is we need to split that data set into train and test. They are data set x train x underscore train test comma y underscore train comma y underscore test. So we will use train test split for this, and we will use IRSS dot data comma IRSS dot target. Yeah. So we will use test size. We will use a test size of zero point 0.4 for this, and we will use the random state. We will use comma the random state equals 0 or 1, let's say 1. And now let's check what all parameters we have for this. So we have it is not showing here. So if you want to see the parameters, you can see it on sklearn-learn.org. You will get all the details of all the packages that we are going to use in this. So you can see what all different parameters you can use here: the data, the target, the test size, and the random state. So let's check what is the shape of the data. After splitting it. Dot shape. So we have in white, and we have 90s. Basically, in y underscore test we will have 90 minus 50, that is 60, I guess. Yeah, so we have 60 in this test data set. So now let's define our model as model is equals to svm.svc support vector classification where kernel is linear. So we have different type of kernel. You can check the sklearn website. We have different types of model there for svc. So we will use a linear model for our, and c is equals to 1. Let's check what all parameters it has. So it has c and kernel. Yeah. So we have defined our model, then model dot fit we will train our model on this data set, that is x test, x train, and y train, and we will check the accuracy of model using model.score. So these are used to check what is the accuracy of your. So model.score is basically used to check what is the accuracy of model. So we will define is that accuracy is equals to model.score on. So we have used xtrain and ytrain for testing. So basically we will use xtest and ytest for testing the accuracy of our model. So let's check this, what is the accuracy of model, and print the accuracy of model. So I have got some error. Init got an unexpected keyword C. So I guess it is capital C. Yeah, it is in caps. So it will. So we have got an accuracy of 0.96%. That's good. That's somewhat good, 0.96%. And we are going to see how we can improve this using sklearn, using KFold cross validation method. So for this, we have cross value score in sklearn, which basically under the hood uses KFold cross validation to uh, to split the dataset, and train the data with different model and check the accuracy of all the models, and give us an average of our how our model performs on all the dataset. So we are going to we need to import that for using we need to import validation score to use it. So we are going to do that as sklearn dot model selection import cross validation score. Okay, so we have defined our model and we are going to see how it performs. So let's check. So score accuracy scores. Okay, scores is equals to cross validation of our model on irises dataset irises dot data comma irises. So we don't need to define the 10 test split for cross validation. So we just need to pass the parameters and the output that we need to expect. So we are going to define cross validation has size of 5. So let's check this scores. So we have got this 0.966666. Okay, 0.9666, and the last one is accuracy of 1. So I guess the average accuracy will be around 98%. So let's check the mean of this scores dot mean. Yeah, so the accuracy is somewhat around 0.98% on all the whole data set. So this is the basic problem this is the basic problem that we face when we split our model into test and train and test data set, and we check the accuracy. So the accuracy is 0.96%. This is because the dataset has been splitted into 90s and 90 and 60 dataset, and we have used the same dataset to test it, and we have not used the dataset in this test to train the model with a different scenario. So this y underscore test might contain data that will have a different scenario, a different angle to see the data. So for this, if you have a dataset that is very small, so for that you can actually use KFold cross validation to validate how your model is performing. So as we can see, our scoring dot mean, we get an accuracy of 0.98 percentage. So now actually what this cross validation does is, under the hood, it uses KFold or stratified KFold strategies by default. So we are actually going to define KFold cross validation, and we are going to check how it performs with this. So now what we are going to do is, we are going to actually use K4 cross validation to check this cross value score. So we have already imported KFold, so we don't need to use it, and we have already defined the KFold cross validation. So we are going to just copy this and paste this and use this as our use KFold to evaluate our model on cross validation square. So let's copy this and use this as CV is equals to this. So now we have defined our K-fold and we have defined our cross validation score for this. So now let's check what is the score for this using K-fold cross validation. So dot mean, we have got an accuracy of 0.966% mean. So you can actually see that here the score the scores of mean was 0.98%, and here the score is 0.96%. So under the hood, what cross validation score does is it uses K-fold or stratified K-fold. So what we need to do is we need to check whether with stratified K-fold it gives an accuracy of what we have got earlier. So let's import sklearn. So for this we will use form sklearn dot model underscore selection import stratified K-fold, and we are going to define our stratified K-fold as. So we will use the same, we'll just copy paste this and change the parameters. So for this what we have is K-fold, no, we have stratified K-fold. So SK-fold is equals to stratified K-fold, where the shuffle study is 5, and we have SK fold score is equals to cost validation RSS dataset CV is equals to SK fold, and let's check the accuracy for this. So we have mean is, and yeah, so now as we can see this the mean the mean of the model using the mean accuracy of the model using stratified K-fold is 0.9667, which is greater than what we have got earlier. What we have got earlier, and it in turn it is actually way more than what we have got using trained test split. So using trained test split, the accuracy that we got is 0.96 percentage. So you can actually use K-fold cross validation or stratified K-fold cross validation when your data set is actually low. So here the data set was 150, one total 150 rows we have in this data set, in this IRSS data set. So now this tutorial comes to an end, where the actual motto was to show you how you can use K4 cross validation to validate your dataset or validate the accuracy of your model on different dataset using splitting the model using K4 cross validation to actually test it on different bunch or different splits of your model. So as we can see we have actually increased the mean accuracy of the model on different splits of dataset, and we have seen that the model performs really well on the dataset. So this is it, guys. And if you like this video, please press the like button and subscribe to my channel, so that whatever updates I keep on posting on Node.js, Golang, and machine learning, you will get it as soon as I upload it. So please subscribe this channel and press the bell icon. Thanks. Goodbye.